The focus of this lesson is on graphing piecewise functions. So a function is going to be broken into different pieces, and those different pieces are basically rules, or output rules I call them. And those rules are dependent on different parts of the domain. So depending on what part of the domain you're working with is what rule you end up following. So let's go ahead and take a look at the example we have here. We have f of x and it's broken into two pieces. The first piece is that your f of x equals the absolute value of x. So I'm going to just kind of put y equals the absolute value of x since it's basically the same thing. And that's when x is greater than or equal to 2. So I'm going to put that also in my table just so I can kind of have it all right there. And then for my second piece, which I'll just use a different color, my f of x is 2. So it's the constant 2. And that's when x is less than 2. So that's the requirement. So you can see that the breaking point of where these pieces break up is at the x value of 2. So what I usually do is I list that as my first x, my breaking value, like where the graph breaks into pieces. Now on one piece it's defined and on the other piece it is not. So if you look here, for the first piece it says x is allowed to be equal to 2. So I know for sure that it's defined at x equals 2 because it says x can be equal to 2. So I put like a little closed circle just to let me know that I'm going to actually have a point physically at x equals 2 for that first piece. But for my second piece, you can't actually be equal to 2. You can be less than 2. And so I'm going to just kind of put a little open circle to signify that, well, we're not actually defined there for the second piece. Okay, so then the next thing I do before I go evaluating anything is I look at the domain pieces. And I see for this first piece here, x needs to be greater than or equal to 2. So it could be 3, could be 4, could be 5, etc. On and on you go, right? For the second piece, if x is less than 2, that means my x values can be things smaller than 2. So 1, 0, -1, -2, etc. And I kind of pay attention to the function as I'm picking my values as well, and I kind of pick my x's intentionally to go with that. So then now all I need to do is I need to follow the rule for each piece. So when x is 2, y is the absolute value of 2, which is just 2. When x is 3, y is the absolute value of 3. When x is 4, y is the absolute value of 4, and you get the idea. And so I'm just going to go ahead and fill in those values. For the second piece, when x is 2, it's technically undefined there. That's why I put that open circle. But when x is 1, y is 2. When x is 0, y is 2, etc. Everybody gets a 2 for their y value, for their f of x value. So then now we can go ahead and graph this graph. So I'm going to go ahead and do the blue piece first. So the first piece of the piecewise function. So at 2, 2, so go 2, then go up 2, solid circle, and then 3, up 3, 4, up 4, etc. So you can kind of see that you have part of the v of the absolute value function forming. So I'm just going to kind of connect the dots. Wasn't perfect there, but you get the idea. A little off on my graph. And then normally this would be 2, but we know it's actually undefined So at 2, 2, we're undefined. So normally I'd put an open circle here, but a shaded circle combined with an open circle stays overall closed. So the closed shaded circle wins. And then 1, 2 is defined, 0, 2, etc. So you get this constant function, which is a horizontal line. So you get part of that horizontal line. And these will connect up because you have that little open circle there. So there's no gaps. That's why I do it that way. That's why I put the breaking point on both tables, just so I can not have any gaps here. Otherwise I might accidentally start here and I have a gap in my pieces, but I have to account for all these values between x is 1 and x is 2. So that's graphing a piecewise function.